Hey class, and welcome to part 8 of Understanding Lighting Efficiencies. This section will be focusing on controls. So the first, most basic control is adding a simple timer to lights. And this could be done on an individual light basis, but oftentimes it's set within the whole building automation system, or BAS. Sometimes it's referred to as an energy management system, or EMS, but it's a central hub for controlling all of the HVAC as well as lighting and security aspects of the building. Just because it's ideally programmed within that automation system doesn't necessarily mean the lights are abiding by it or the wiring or controls have been set up properly. So it's worth doing a night walk or a night walk through with the building operator to just make sure that the lights that should be off at night are indeed off. And these timers are great for offices with regular schedules. If people are leaving around 6:30 or so, then you can know that you can shut down most of the lights in the space with, say, like a manual override. You could add some timers to, say, the exterior lighting for after dark hours as well. Here's an example of a timer gone awry. This is an office in Idaho. And the night lights, these lights that should stay on all night, this timer was actually overriding the rest of the controls, which were dimming and even shutting off the rest of the lights because it had enough natural light. So these lights had something called photocells or photosensors, which are kind of the next branch of controls we'll talk about. And these can control individual lights or a whole set of lights in a space. If you've ever seen a street light with a little blue cap, sometimes a black cap on the top of it, there's a little photocell embedded within it that's basically sensing the illumination, the light intensity falling on it from the sun, and when that drops below a certain level, the light should turn off. There are more sophisticated versions within offices, of course, to actually provide a certain amount of illumination on a desk. And so as you get more or less light, the light output, the number of lumens that the bulb is producing will actually rise or fall as needed to produce that same amount of illumination on the space. And that's great for any area with a skylight, exterior lights that aren't on a timer, and it's now being required more and more in the Idaho Building Code for perimeter offices or daylighting zones. The actual requirements vary a lot depending on the actual space. There's a couple pages in here on when they are or are not required, but generally, if you have windows nearby or a skylight, new lights are going to be required to have some sort of lighting power reduction through a photocell or dimmer. And this just makes sense, right? Because here's an example of a gym where the lights are off in this top photo, and the same exact gym down below, you can see the skylights were providing plenty of light, but since the artificial lighting in here, the lamps didn't have any photocells embedded in them, no photo controls, they would stay on throughout the day unless somebody turned them off. And it was just unnecessary and causing this kind of grosser, kind of warmer color during the day that doesn't contrast very well with the natural daylight. The third control type for lights is motion sensors. You've seen these with, say, security lights, a little infrared sensor that detects motion. These are great for, say, janitorial closets or break rooms, low occupancy, but somebody might walk in there every once in a while, and this is a nice way of automatically shutting the lights off after they leave, as well as making sure that, if somebody is stuck within the office, say at 7 p.m., and there's a timer, so the rest of the lights went off, but the cell here detects occupancy, it'll light back up so that that person's not left in the dark as long as they keep moving All right, so those are the three kind of main control types. Another note on motion sensors is they're only allowed in certain areas. Uh, you're not allowed to have motion sensors in kind of more dangerous environments, say like manufacturing or something like that, where it's absolutely vital for safety that the lights stay on. And that's not really covering any of the egress lighting either. One up and coming trend is to have all of these controls embedded within the light itself. And this is called luminaire level lighting control, or LLLC, something that the Northwest Energy Efficiency Alliance and some of the utility programs in the Northwest are starting to incentivize and push. Here's an example of a light that we got to play around with and installed at a building here in Boise, where it has several different sensors all embedded within it, including occupancy, sensing the ambient light within the space, and it could also communicate to the lights around it. So not only would one light go on, but say the three around it would also come on. So you could get this nice little spotlight that would follow you as you moved through the building. It seemed a little sci-fi-ish. It was very fun to actually walk through the building at night and have the lights kind of turn on and turn off behind you. So just something to be aware of. They're on the pricier end of the spectrum, but instead of having everything centralized in a building automation system with requiring a whole bunch of lighting, now prices have come down enough that you can actually embed all these sensors light by light, which is pretty neat, and they can operate autonomously. In terms of measuring savings from these guys, I like to use a little Hobo U12012. They're similar sensors out there, but this provides easy data logging. It's very quick to set up. It's got a little button on the top that senses lumens per square foot illumination, foot candles, to sense, if the desk is getting enough light with or without artificial light, and to make sure that the lighting schedules are doing what they're supposed to do. And the last energy savings kind of problem I had you guys do, we were looking at an efficacy upgrade, so lights that were providing enough illumination but using fewer watts to do so. When we're looking at savings in terms of energy, you have to take the number of lamps within the space, multiply it by the difference between the old lamps that used a lot of energy, subtracted from the new watts used from the more efficient lamps, multiply that by the hours of operation, you get watt hours, convert that to kilowatt hours, 1 kilowatt hour per 1,000 watt hours. I need to add that 1,000 down there. But then you get kilowatt hours of energy. And you can multiply that by a simple utility rate in terms of kilowatt hour or dollars per kilowatt hour, and get a general ballpark of how much this might save. There's a lot more that goes into that, of course. There are possible peak reductions where you're just looking at the watt reduction and not necessarily the energy, but just the power reduction, as well as, say, maintenance costs and incorporating capital costs. So it can escalate in terms of complication rather quickly, but this shows you the basics. For controls, it's a little bit different. Still just rely on common sense, but count up the number of lamps within a space, multiply it by the number of watts used by each lamp, and then what you want to do is multiply it by basically the hours in a year that those lights are now going to be off thanks to the new controls. So say the lights used to be on 24/7, now the lights are on just say 7 a.m. to 7 p.m. So that would be a 12-hour savings. Multiply the watts by the hours of savings. You get watt hours, convert that to kilowatt hours, so divide by 1,000, and then you've got your kilowatt hours of energy. Another thing to consider, though, is especially talking about incandescent lights, right? They require a whole lot of energy to run, but the energy that they're outputting, a lot of that is in the infrared spectrum, not necessarily the visible spectrum, and they're adding heat to the space. So the lighting power density, all of those watts per square foot, are eventually coming out in terms of heat. And so that's adding to the internal load of the space, which has to be taken care of by the HVAC system. So if you do a huge upgrade and you convert all these 100-watt fixtures down to 10-watt fixtures, you're removing a whole bunch of heat sources from the space. That's going to be great during the summertime because it means less cooling, so you're going to have some cooling savings, but it can come with a heating penalty because you no longer have that heat source within the building during the wintertime. And sometimes that heating penalty can be pretty significant, and buildings, owners, or ratepayers aren't necessarily expecting that, and can be hit with a much higher winter bill that they weren't anticipating. So another thing to consider, and that's where we'll move on to next, is actually looking at heat loads within the building and heat escaping from buildings and envelope considerations. So hope you'll join me next time, and thanks for going through all this lighting stuff with me.